This is homework practice 2.7. Number 1, they give you this graph here and they say use it to determine if the regression model is appropriate. So is the linear regression model appropriate here? By looking at the residual plot, it has a pattern that is not linear. Therefore, linear is not appropriate. Okay, number 2. Okay, looking at this graph here, we want to know again, is the linear model appropriate? With the residual model, yep, you want to see a good scattering with no patterns there. So yes, linear regression model is good. Okay, number 3. Okay, so this one here, also once again, use the residual plot here to determine whether the model is appropriate. You see a good scattering across. This one kind of is down there though, but yes, linear regression is appropriate, is good. Okay, next one. We have random sample of 195 students from the UK. Height. Okay, so if you think about the shape of it, what's happening here, this is the height, and x is the age. Okay. You had a least squares regression line, and the standard deviation of the residuals is s equals 8.61. Okay, so what does s mean? Okay, so s is the residuals. So remember, if we have a bunch of points, they have residual. Residual is an error, how much error there is. So there was an average error of 8.61, and height, it was in centimeters, when making a prediction. Okay, average error in height, I should put that in there too. Okay, when we're making a prediction for height, we were off by about 8.61 centimeters when making a prediction. Okay. Okay, the next one. Okay, I don't know if you've ever done this experiment. Put Mentos in Diet Coke, okay, and see it, explode out. So they did either 2, 3, 4, or 5 Mentos into random bottles, and waited for it to fizz and measured the number of cups remaining in the bottle, so how much soda is left in there. Then they subtracted the measurement from the original amount, okay, and here we have the amount expelled, so how much did the number of Mentos went in. So if there's 2 Mentos that went in, how much soda shot out of it, okay? So we got an S equals 0.067, okay? So S is once again the residual is an error, how much error there is. S is the standard deviation of those. So it's sort of our average error. So we can say there was an average error in the amount expelled. The average error of 0.067 cups when making a prediction. Okay. Okay. So we're thinking about that. This one here, when we talked about height versus age, okay, and it gave us an r squared that was 0.274. Okay, so we're going to interpret that. Basically, the 0.274 is how good is this a predictor of height? Okay, Now, there's other things that make predictions of height too, right? So, like genetics is a big predictor of height, how big your mother and father were, some other, the amount of protein and nutrition that you've had as you've grown up. A lot of different things go into height. Age is one thing, right? As you get older, you get taller, but that's not the main thing. Okay, so that this tells us that it's a pretty low predictor. Okay, but we would say 27.4% of the variation in my y variable, and my y was the height, can be explained by the age. Okay, so 27% can be explained by the age. That means there's another, 72.6% that is can be explained by other things like genetics or something like that. Okay. Okay, so thinking about the Mentos one. Okay, so we had an r squared of 0.602. So we would say 60.2% of the variation in expelled soda, okay, how many cups was taken out, can be explained by number of Mentos put in. So the more Mentos we put in, the more soda that explodes out. 60% of that is due to the Mentos. There's another 40% that is due to the, I don't know, the temperature of it or something else, another variable there. Okay, next problem. Do quarterbacks matter? Okay. So how important is the quarterback skill to the success of an NFL football team? One way is to the quarterback's effectiveness is with the quarterback rating, a complex calculation based on passing accuracy and yardage, touchdown passes, interceptions. So if we created a least squared regression line model for AFC teams relating Y as the team wins and X is the overall quarterback rating, okay, we get the following residual plot. Okay, so this isn't the plot, this is the residual plot. This is the plot of the residuals. Okay, so part A, is a linear model appropriate? Okay, so in the residual plot we see a good scattering. So yes, linear is appropriate. Part B, interpret S. So we would say there was an average error of 2.473, and our Y was the number of wins. When we're thinking about how many wins, there was an average of 2.473 wins when making a prediction. From the quarterback rating. So when we're making a rating by quarterback, okay, we're making a prediction of how many wins a team's going to have based upon the quarterback rating. We're going to have an average of, we're going to be off by an average of that many wins. Okay, part C, okay, we would say 45.7% of the variation in wins can be accounted for by the quarterback rating. Accounted for by the quarterback rating. Defense and some other variables other than just the have a big impact on the number of wins a team has. So you can see that number there. Okay, the last problem. Okay, so once again, we're talking about this in height. Suppose the heights of the students were in meters instead of centimeters. This changed the effects of S and R squared. Okay. So the S is the average error. Okay, so if our numbers if we're thinking about the number of meters versus centimeters, okay, so we're thinking about S is the average error. So if we're thinking about how many centimeters somebody is away versus how many meters somebody is away, like if somebody say is 100 centimeters away, that's only 1 meter away. So if I put it in meters, the distance away is going to be less. It'd be 1 meter versus 100 centimeters. So the S would be smaller for meters. The average error would be less, right? We'd be less meters away. Even though it's the same distance, right? It's centimeters and meters, it's the same distance away. But this distance is, like between my fingers there, that distance is bigger in centimeters than it is in meters. Okay, so we're thinking about that. R squared would not change. Hey, that is your homework.